So, all right, quiz 5 preview. Lots of things to take care of here, so we'll jump on in. Okay, first part, solve by taking the square root. Notice how we've kind of put a little importance here. The lettering's a little bigger. Okay, show all work, and don't forget the plus minus. And again, the plus minus comes from the fact that these are all quadratics. That 2 means there's 2 answers. But my first job on any of these is going to be isolating that x squared term if I can, and no matter which form it's in. So for me to do that on number 1, what should I do first? Okay, we need to minus that 17 out of there. We need to do an opposite, just like we would if it was just x there. So I go ahead, I get that minused out. And then my last step with these, at the very end, last step only, is to do the square root. And again, hopefully with the reminder up above, because squared and square root are inverses. Remember, plus minus, whether it breaks down nice or not, and in this case it does. Okay. Plus or minus 6. That's all I can do. There's nothing else to put with it, break down, anything like that. So that's all I'd have for number 1. Now number 2 gets a little bigger, because now I still want to isolate my x squared term. So I start similarly to how I started the last one. But this time I can't take the square root when it comes to step 2. I'm not quite ready for it yet. What do I still need to do to get x squared by itself? Divide by 3. Great. So we get that set up. Now I'm down to just x squared, so I can do my square root. But there's one little added part this time. Okay, I know the plus minus is coming. But this time, if I wasn't sure, if I went to my calculator and I punched in the square root of 18, uh-oh, it's a decimal. We do not want decimals. No decimals. So I can't just write square root of 18. I need to at least attempt to try and break this down. So I need 2 numbers. But one of those 2 numbers, I can't just pick any 2. One of them has to be a perfect square. Okay, and again, your green sheet's usable on the quiz. So if you're not sure, you can take these. So what I'm going to do is I'm going to start trying to divide some numbers into 18. But this time I think I'm pretty sure how this is going to turn out, because 18 divided by 9, which is a perfect square, is 2. So my numbers over here are going to be 9 and 2. But again, it's the square root of those numbers. The square root of 9 is my perfect square. Gets out of radical jail with a new identity. It's 3. The 2 is still acting irrationally. It has to stay under, and I'm done. Now, some of you may say, well, what if I left it as plus minus and just put square root of 18? Like, for instance, on this problem, this would be a 3-point problem. I'd probably ding you for like 1 out of the 3 for not breaking it down. It's not the worst thing ever, but we know we can do better. So just something to consider. Okay. Now, the first 2, x squared's been by itself. Now this time it's a little different. My job turns into getting the term where x is by itself. Okay? Since I'm multiplying by 4, I'll divide by 4. Now, a couple of things I can't do. Let's talk about those first. I can't distribute the squared. First of all, mathematically it's not correct. And second of all, it's not going to get me where I need to be. So, nope, don't want to FOIL it out. Since the squared's in the way of me getting to this, here's the one exception where I can go ahead and do the square root before I have my x isolated. Because the squared and square root, again being inverses, is going to give me the chance to get to my x here in a moment. But before I get there, whenever I break down a radical, I always have to stop and think for a minute. Are there a pair of numbers, or is a perfect square a factor of 24? 6 and 4. Nice. And again, I'm a fan of writing it out so I kind of can remember how this works. So I go, okay, square root of 4 is 2. 6, yeah, not so much. But I have one step left because x isn't alone yet. I have to add this 2, and here's where our last pitfall could possibly come in, and we got to be careful of. Okay, this 2 doesn't have a radical with it. I can't combine it with this. They can hang out on the same side of the problem, but this isn't a situation like if this were just a number where I can do 2 plus 2 and 2 minus 2 and get the answer. It's not. It has a radical, so I got to stop. Okay. Kind of think of that radical like you would a variable term with like terms. They're not like, so I can't put them together. Okay. Issues. Okay. Oh, gracious. Here comes the F word. I even made it big. Okay, factoring. Now, again, you've got your green sheet to assist you at least in letting you know how things set up and how you would go about doing it. Okay? And really, the only part of the chart we need is this part because we haven't gotten to the 4 terms part yet. So it's just these 2 guys. So I always look first. Let me put it up here. Here's my golden rule, which is always the first thing I've got to do no matter what it is with factoring. Do they have anything in common? Always ask the question, even if you're not sure if there is or not. Here, I don't think I can do anything. I could divide these guys by 2, but the x squared I couldn't divide by 2. So that's not going to help me. Now, these 2 guys both have an x, but the 24 doesn't. Okay, I can't take anything out. Now what? There's 3 terms. No number in front of x squared, so I do it like the diamond problems. If you're visual and you want to see the diamond, let's do that. But as we've said before, there are clues here all over the place. Nice, okay? Now, if you don't see that right away, here's what I was talking about with the clues. When I multiply to get a positive, one of 2 things has got to happen. They're either both positive or they're both negative. Well, since they add to a negative, I know that both numbers have to be negative. So I need 2 numbers that multiply to 24 and add to 10. And as I've already mentioned, that would be 6 and 4. So I put my minus 6 and my minus 4 over here. But again, solve. That equals 0 means we take each set of parentheses, set them equal to 0, and actually get the solutions. So I add my 6 to both sides. I add my 4 to both sides. Okay, and get my answers. You've got to use the factoring to get there. You can't just start plugging numbers in, find numbers, and go, woo, I'm good, because it's gonna bite you later. So that won't work out well for you. All right, so I get to 5, like 36 and 81. Is anything going to 36 and 81? Oh, no. But wait a minute, let me look at those for a second. Hang on, 36 and 81. Wait a minute, oh, 36 and 81. Hey, all right. Perfect squares, okay. So what's that mean? Well, oh, even better. The form's right on your sheet. Whatever I square to get each term, I write in, and I put a plus and a minus in the middle. Okay, I can do this. So I got a plus and a minus. What do I square to get 36x squared? 6. 6x, yes, don't want to forget the x, good. What about 81? 9. Okay. And just like that, I'm factored. And I can go ahead and minus my 9 over. Over on the right side, I'll plus my 9 over, because again, I'm doing opposites, because I'm trying to isolate here. But here's my one last thing I'll mention. You're like, Harty, is there a problem where there's not a pitfall of some sort? A lot of times, no. Because I get here and I've done all my math work perfect and everything's gone great, but there's a couple of things to make mention of. First, we always want to make sure things are simplified as far as they can go. And again, with math enter, that shouldn't be a problem. So make sure when you get to the end that we reduce. And the other thing that I will admit, I boneheaded a little bit on this. Yes, it happens. I went and I was so excited about seeing the perfect squares, I really didn't think about the golden rule at all. So I'll show you that I'm going to get the same answer either way with this, but here's how this is going to work. So what if I'd have really done the golden rule when I started? Would it have changed anything? If I'd have really tried, I'd have noticed that I can divide 9 into both of these. So if I would have taken out the 9, you're like, oh, well, that's kind of different. Well, guess what? They still were perfect squares, and I still would have been able to go through. What do I square to get each one? And I'd have just set these equal to 0, and guess what? I'd have gotten the exact same answers. So you're like, are you telling me I don't have to follow the golden rule? I'm not saying that, but notice when I do it this way, I didn't have to do the reducing at the end. I'm sort of foolproof here. If I do everything the correct way, it will make life easier on me to where I possibly won't get all the way to the end and then leave it as 9 over 6 and get a little bit off because I didn't reduce. Okay? So it's a minor detail, but it's something to think about. Okay? Always try to make sure that you're looking for your golden rule to make sure that would work out for you. Just something to ponder. All right. Number 6. Anything in common? You're like, let's see here. 3 go into all those? No. And I can't really do anything else because I was going to say I could put a 1, but 1 doesn't take anything out. All right. Well, I guess I can't do anything with that. So let me get this posted out of the way. So like, okay, I'm stuck. There's a number in front of x squared. Okay. Guess and check or slide and divide. Well, we tend to have gone with slide and divide because the guess and check's been a little strange. So we'll slide this guy down here. And again, like this with any, the more practice you get, the easier this gets. So I get here and I go, okay, Harty, these numbers are a little big. That's okay. Let's think about some things first, though, before we jump in and start looking for numbers. Multiplies to get a negative, which tells me one sign's going to be positive, one sign's going to be negative. I also know that they're going to add up to 16, which tells me this is going to have to be the bigger number, because that's the only way I'm going to get a positive sum. So now that I've thought about that, I'm like, okay, 2 numbers that multiply to 105 and are 16 apart because the signs are different. I could either go to the back of my chart and start looking to see where I see 105 and find a couple that work that way. That's an option. Or my other option would be to just start playing with this a little bit. So I start playing, and I'm like, okay, so let's see, 3 and 35. Nope, that's not far enough. Yes. Nice. Just as I was about to go to 5, you beat me to it. Even better. 21 and 5. Okay, they're 16 apart. So I get my 21 and 5, but be careful. Yes, I have to put the 3 back in. I got to do the divide part. If I just set these equal to 0, I just did all that great work and I didn't even get the right answer out of the deal. So I got to divide by my 3. If it goes in nice, that's terrific. What if it doesn't go in nice? Yeah, I make sure this is reduced. 5 over 3 is its most reduced form. Bless you. And I stick that back in front. I've fully factored it. And now I can actually work on getting my answers. Oh dear. Add my 5 over and divide by 3. But again, it just takes a little bit of patience. Plenty of time to get it all done, so it's not got to go in a hurry. We just got to make sure we're doing it good. Now, those things are things that have been a little while. You know, we're a week back, so that can take a little bit of time to kind of get renewed into your head. Now, I'm hoping these next 2 parts are going to go, you know, quicker for us, make us feel a little more comfy. So, bump up and over here a little bit. Okay, solve by completing the square. We've done a ton of this, so we got this. All right, first thing with completing the square, what should I do on 7?
Add 8.
Add that 8. We got to isolate our x terms. Nice. Okay, once I get here, you know the deal. Take that b, have it, square it. Try to get the idea of Harty singing out of your head. Some of you probably already have. I just brought back nightmares. I apologize. And make sure that 4 gets added to both sides, not just the side where we're going to be making our perfect square trinomial. Once I get that 4 added in, the question becomes, going from the perfect square trinomial to the binomial term, what's going with my x?
2.
Okay, my b divided by 2. So my 2 in this case. And now it looks a lot like basically what we dealt with up in number 3. We got to square root it, which we know from our experience means I got to have a plus minus, which from our experience knows, ooh, I better make sure I can't break the 12 down. Oh, wait, I can. Multiplies to 12, and one of the numbers is a perfect square. Nice. Four perfect gets out of radical jail. 3 not so much. I'm going to run out of room. I need to make myself a little more here. What's my last step going to be? Subtract the 2, because I need x by itself. So, yes.
No, I did the whole thing, but I didn't do it. Like I kept on forgetting to do it.
Oh. Now again, this is, I mean, there's a lot of points in this. This is probably a 4-point question. So I mean, if there's only one little thing you do somewhere, you lose 1 out of 4, it's not the worst thing ever. But again, if we're going to get to all that work, just again, take your time, make sure things are looking good for you. All right. One more of these. Let's use number 7 kind of as our guide here. Get our constant term out of there. We're doing super. Again, and again, some of you have come up to me and you're doing this in your head, and it's going okay, and that's fine. I still think that there's value to you writing down the side step, just so things are a little more obvious on what you're going to add to both sides and also what your b divided by 2 value is going to be. But again, that's your call. So, plus 9. And I will make mention of one other thing as we put that in. Remember, when you're squaring your b divided by 2, okay, reminder those parentheses need to be there, because some of you I'm still seeing coming up with negatives on this. Never should be a negative. This is always going to come out as a positive. So make sure those parentheses are being used. Okay. Squared. What's going in the parentheses with my x? -3. Okay, I've got to make sure I take the negative with me. That's why I like writing the step out. So I get to there, and I'm like, okay, now I kind of got this as my guide. I'm going to do my square root. Harty's going to work sideways here. Squared and square root are inverses. Plus minus. Ooh, it's a perfect square. And so now when I add my 3 over, and here's our exception to where we can actually split, kind of divide and conquer, I guess. Since there's not a radical there, I can put things together. I can look at this and go, ooh, 3 plus 5 is 8. Ooh, 3 minus 5 is -2. If there's no radicals, there's no reason for me not to be able to finish it. So I just work that out and get that set. Okay. So I look and I go, okay, this ain't going terrible so far. We're just going to take... That's the answer, these two guys. Yep, just want to get that completely worked out to make sure we've got everything working for us. Okay. Now this next one is going to be, again, this kind of goes back towards Friday. It's towards what we were doing with the circle, but it's vertex form. Now remember, vertex form, oops. Okay. It's going to work like our circle one does, except I'm not going to have to do it twice. That's kind of nice. So if we go back to vertex form again, okay, I'm not going to get the 20 out of there like I did before. Remember with this, I'm going to put my blanks in right away just so I can remember where everything goes. And if I can remember to put an equal sign in, silly man. Once I get that first step done, knowing I'm going to add it to the y side, and I'm going to add it with the x's on the other, we're still going to kind of isolate our x's using the parentheses. I do the exact same stuff I've been doing for the last two. Take my b, divide it by 2, and square it. There's my number to go in the blanks. And I'm actually going to get done with this one really quick this way. It's kind of nice. I've got to get my trinomial turned into its binomial form. Okay, nothing changes on the left yet. We'll get there. On the right, what goes with x? -5, my b divided by 2 number. And now to get to vertex form, I'm looking back and forth and going, okay, oh, I just got to get the y by itself. So I got to minus my 25. Okay. There's my equation. If you don't want to have to rewrite it, just an arrow there saying, woo, that's what it is. I'm good. But from that, what's the vertex? 5, -5. Because again, it's the opposite of h, so it's the opposite of what's inside the parentheses. But then it's plus k, which means whatever this is, that's what that value is going to be. Okay. Issues so far, we're doing good. I'm hearing people talking to me on answers and stuff. I'm a happy camper. All right. Now we crank it up a little bit. Okay, the area of the rectangle shown is 65 square meters. Remember, area of a rectangle is just length times width. So find the value of x in the dimensions of the triangle. You can use your calculator or solve by hand. To me, there's going to be so many things on the calculator that can mess you up. I think this is going to be our better route. So here's how we're going to do it. So I've got length times width equals my area. So, when I get here, I've got to multiply my x through, distribute it through. And then I'm going to want to factor this. So I need everything on the x squared side. So I'm going to minus the 65. Back to the left, so I get equals 0. That's the key. Once I get to equals 0, I can actually do this. So I'm like, okay. And we're back to doing slide and divide. So I'm going to slide that guy down here. Let me scooch this over a little so we can make sure we stay in here. So my 2 got multiplied down, and I'm probably going to have to do a little work here with the chart or maybe with a calculator. Because I look and I go, okay, multiplies to a negative, one of each sign. Adds to a positive, means this is going to be bigger. So I need 2 numbers that multiply to 130, but are 3 apart. 10 and 13, but yes. You were close. You had the 30 part down. So 10 and 13. And again, if I have to play with the calculator for a bit or my multiplication chart, that's okay. And we said the positive was bigger. So we're good there. Be careful. That 2 that we slid before, it's got to get divided back in. So I punch in 13 divided by 2. I get a decimal. I look, I math enter. Is it still 13 over 2? It is. So 2x plus 13. 10 divided by 2 goes in nice. Makes me happy. And so now I just about have x. I just set those equal to 0, and I can figure out how this works. Now let's see. I know. I'm looking at this, and I'm like, I'll steal space over here. I got space to work with. So I work these 2 little mini equations out. But once I do, I have to think about this for a minute. So I set each set of my parentheses equal to 0. I get that set up, and I go, hey, got 2 answers here. Do both answers work? No. Which one doesn't? Yeah, the negative 6.5 doesn't work. I can't have a negative 6.5 side. That's like crazy. So my x value is 5, but I also want to know the dimensions of the rectangle, and that's not a hard deal.
Oh my goodness.
Okay, all I'm going to do is plug it in. 5 goes in for x. Okay, that was easy. 2 times 5 is 10, plus 3 is 13. Okay, that wasn't bad. But it is. It's doable. I just got to work at it a little bit, kind of keep playing. But you start to see where this kind of comes in a lot of spots.
How many points is it going to be worth on the 10?
Like this whole quiz?
No, this whole that we just did.
Oh, that problem? Well, let's see. Setup would be a point. Distributing through would be a point. Factoring it would be a point. Finding x would be a point. The dimensions, that's probably a 5-point question.
Aren't all these questions in the backside like really old?
Really old? No, actually. The ones when we get towards the end here on 11, 12, and 13 actually are like the last things that we were doing in Unit 1 before we got here. Actually, no, let me take that back. We'd actually done a graphing quiz with this stuff. So, no, it's actually within about the past...
So we can like cut this out.
No! See, in math, things build. This isn't like, and I'm not going to pick on any particular class here, but it's not where you can say, oh, I've done that. Well, that's out of the way. I don't have to ever think about that again because I'm just moving on. A lot of this stuff combines and builds, and you see it again and again in different forms. So, no, when we're doing quizzes and stuff, the review stuff's going to keep coming back because there's going to be a reason that we're going to need it one time or another. So we're going to kind of keep playing with this a bit.
Wait, but the dimensions of the rectangle is 5x 13?
5 by 13. 5 times, yeah, it's just 5 by 13. Okay, parabolas. They don't go away either. Standard form, reminder. When I'm doing this, I got to find my vertex first. That's my key with all of these. So we're going to simplify things. Okay, that's the only little tiny formula I need in this whole area. Negative b over 2a. So let's see here. Negative 8 over 2 times 2. Here's why I said that's the only thing I'm going to need. Okay, my vertex x value is negative 2. You could plug that in for the x's and work it out algebraically, but I'll tell you what I would do, because I'm going to use this in a minute anyway. I would type my expression into the calculator, and I'd go to the chart, and I'd get the negative 2 in the middle. Now, 2 reasons for that. 1, I see the symmetry, so I know I've got my x value right. And 2, there's the y value. I don't have to even calculate it. That's kind of nice. So negative 2, 5. And then from here, just use the chart. I mean, you can use the pattern. We've talked about the pattern before. But otherwise, just kind of take a look at the values on the chart. Get those other points plotted. I would prefer that if possible we get 5 points, because sometimes if we get 3, the temptation is to make a V shape, which is an absolute value equation, not a parabola. If you make 5, you start to see more of the curve that's going along with it, and it makes it easier. But again, the whole key is one little tiny thing there, just to remember how to get my vertex. And to be perfectly honest, if you just typed it in on your calculator and started scrolling up and down the chart until you saw symmetry, you could get away with that if you forgot. I didn't say that. Oh, wait, I just put it on YouTube for everybody to see. Oh, well, that's life. It will be. As soon as this hour is done, it will be uploaded. Okay, so now, next one, I don't even have to do that much work. What's my vertex for number 12? Nice. Negative 4, 2. Axis of symmetry is x equals negative 4. It's just my x value of my vertex. Okay, now, focus and directrix. Here's reminders on those, but again, remember, I don't leave you guys hanging on this. These expressions that you're going to need for this will be up somewhere, either handed to you or on a board or something. Because I want you to calculate it, but I don't care about the rest as much. So, okay. So let me get this stuff written in for you. Okay, these are the little formulas we had before. We had a cheat sheet for these before. Okay, that we were using to remind us how to calculate these. Now remember, you've already got the h and the k part from your vertex. So the only value I need is a, which is the number in front of the parentheses. So my a value is negative 1, because there's a negative right there. So now I just got to plug these values in to get my focus. So I'm like, okay, so h. Now for the second part, I'm going to do a little side work here. It's k plus 1 over 4a, which is negative 1. 4 times negative 1 is negative 4. So this is really 2 minus 1/4, or 2 plus negative 1/4, if you wanted to look at it that way. And if you want, I don't care at this point if you go to the calculator. If you look and you think about it, you're like, well, hey, now hang on a minute. If I got $2 and I just spent a quarter, I still got 1 3/4, 1.75. If you go on the calculator, just want to talk about the plethora of answers that are available. If I wrote in 2 minus 1/4, okay, there's the 1.75. If you were to go, oh, Harty likes fractions, I'll do math enter. If you wrote 7/4, I'm fine with that. really don't care. They're all good. And then directrix, notice the only difference. It's just the sign switch. So instead of it being 2 minus 1/4, it'll be 2 plus 1/4. I don't really have to do all the other calculating again. And again, 2.25, 2 1/4. I'm good with all of those.
For number 11, how did you get 5?
I straight went to, I'd already typed it into my calculator like this, and I went to the chart, and since I knew the x value was -2, I just looked and saw what the y value was over there.
Oh, okay.
Yep, kept life simple. Now here, again, I have choices. I could type this into the calculator and just use the chart. That's perfectly acceptable. But we've talked before about the pattern. So like here with the -1, I could just go down 1 and over 1 each way. And then go down 3 and over 1 each way, because that's how the parabola pattern works. So either one will get you a perfectly good parabola, but it better be opening down, that's all I'll say, because I have a -a value. But again, typing that into the calculator using the chart, same thing. Happy both ways. All right, deep breath. Last problem. Gracious, it's the longest 13-question quiz preview in the history of man. All right, Lexi throws a softball up in the air. The height of the ball can be modeled by this function. We give you this equation, where x represents the time elapsed in seconds. Use your graphing calculator to find when the ball hits the ground. Find the 0. So again, we've done this before, but we're going to jot this stuff down. Make sure we got this set. Not enough room. Oh, there's plenty of room. So we're going to go to y equals. We're going to type this equation in. So -16x squared plus 14x, there's my x, plus 7. Okay. Find the 0. Well, first I'm going to look at the graph.
Isn't it just the last number?
Ooh, now that would be my y-intercept. That would be my starting point, the 7 would be, but it won't be my answer here. Because that value would actually be this number up here where it starts. For the 0, I'm looking for where it hits the ground. Right here is what I want. So here's how we do it. We do second trace. And we want the 0. We want number 2. And we're going to go trapping this. So here's how this works. Right and left arrows only. See my little cursor guy? I want him over here. So I'm going to start going to the right. Watch the y value. Okay? When I do this, I want my first time that I hit enter, when it says left bound, to be a positive y value. Any positive y value. It does, oop, that's not a positive y value. Get it? There'd be okay, here'd be okay. Positive y. Hit enter. Then I start going, and I hit enter again when it's a negative y value. You're like, well, why are you doing that? Because here's my parabola, and what I'm trying to do is trap this in. So when I do my positive y the first time, I say, okay, here's the first part I'm looking. When I do the negative y the second time, I say, here's where I'm looking. Calculator, look in between here to find that point that I want. So I hit enter, and then if I want to, I can try to get back closer to where it was and hit enter for my guess. And that x value, okay, because y equals 0 means the ground. I'm not above or below anything, it's just 0. So my x value would be about 1.23 seconds. That's not going to take very long. Now again, this video is online, will be, if you want to be able to check it later. It also gives you things to look at and go, ooh, it's been a while since I did that. Go back, look at something, find it, watch another video with it, because everything's in my YouTube page by units. But if this is the last time you look at anything, you come in tomorrow and you haven't been doing the practice, like with the homework check, which is due tomorrow, it's going to be tricky. So again, give yourself that best opportunity to be successful.